Hello, welcome back to Maths and Mars Physics, and today we're gonna be looking at how strings work in when looking at physics. And so what do we know about strings? Well, in this example, right, we have two boxes, right, which are on a flat ground. No, like that's just a flat ground, right? And then this is a string that's joining them. And what do we know about strings? Well, strings have tension, right? If you hold a string, right, in two hands, right, let's just say you're holding it like that, the more you pull it, the more tension it's gonna have, right? So strings have tension, right? And so in this problem that I already drew out for you, there's two boxes. One is 4 weight and one is 6 weight. There's no like unit attached to it right now, and it's receiving a force of 100 N. And so in these string problems, what we have to find is we have to find sorry about that. We have to find all the tensions and we have to find the acceleration. So let me show you how you can make a equation out of this. So we can every string can only have one tension, right? So if let's say there was like more of these boxes, right? Like 3 of them, right? Like the more you add, the more strings there'll be, right? But like this tension T1 is going to be different from tension T2, right? And both of these boxes are going to be receiving the same tension on both sides, right? It's both going to be T1, right? So that's how that works. And so in this problem, right, which is a simple problem that we can use to start off with strings, you can see there's one string. So we're gonna call the tension here T1. I'm gonna show it on both sides just so you can see it better. So not T1. So here T1 is gonna be pulling on both sides, right? Like these two boxes. Kind of think of these two boxes as your hands, right? They're kind of pulling it a little bit. So this tension is going to be going this way, away from this box, and the tension here is going to be going away from this box, right? It's going to be coming towards the center, right? The more you pull it, think about it, like the more you pull it, the more a stretch is going to be, the more tight, right? So the tension is pulling inwards. So now we can make equations which are similar to how we were doing in the last few videos, which is you look at it like the coordinate graph, right? Like if it's this way, if it's up or down, if it's up or right, it's gonna be plus. If it's left or down, it's gonna be negative, right? Remember we did this coordinate thing, right? It's gonna be the almost the same thing, right? So since there's only one tension, we're just gonna call this T for now. Sorry about that. So we're gonna say T minus oh, okay, we don't need that, right? Because we're writing about this box right now, right? So T is equal to 4A, right? Because we're writing in the form F equals MA, right? So F equals MA, right? Everything really in forces comes back to this main equation, F equals MA. It's all collective forces equals mass times acceleration. So here, the only force that this box is experiencing horizontally is the tension, right? So the tension equals 4A. That's our first equation, right? That's equation 1. Now equation 2. Tension is now the tension is going left, right? So it's going to be negative, and then this 100N is pulling it right. So it's going to be 100 minus T equals 6A, right? Now we have two equations and we have two variables, and we can solve for both now. So if T equals 4A, this is going to be 100 minus 4A equals 6A. So 100 equals 10A. So A equals 10. So we already found A, right? The A here is 10. And now T, right, we put in A. We get T equals 40. And yeah, that is it for this problem. That's how you solve some string problems. And so we'll do something similar to this in the next few videos. So make sure to go ahead and watch those two. Thank you.